any state in the country. We call drivers in this state gold tier clients, the ones we'd fight to keep.
And I want you to check on Desmo, see if it happened like that.
Overcharging you. My neighbor Jessica from Tampa, perfect record, was paying $180 a month for 15 years. I told her, try out my new website. She found the same coverage for $72. Saved 60% after filling out the form through my official website. After 30 years in insurance, here's the truth. If you live in Florida and have 0 DUIs in the last 5 years, you're being overcharged. But they won't call you with a better rate. Why would they? You're already paying too much, and their shareholders love it. I'd quietly tell my favorite clients.
Okay, the graph's gonna look like, hold on a second, let me put on here. But y-intercept is kind of difficult, so because y-intercept I did not teach you. But I want to see if you can figure out.
Was paying $250 monthly for 2 vehicles. He applied and found the same coverage for $65 a month. Think about how much money he saved per year. Here's the
Is the second one going down? Is that three?
All right, so in order to really find the equation like this, you have to go into each zeros, and even in this case, the y-intercept is the most useful point. So that means I'm gonna label this point, this point, this point. I'm gonna label another point, green point right here. I'm gonna use that. I'm gonna use all those 4 points. Now I'm gonna go indicate those multiplicities, right? M is equal to what? 2. What is M equal to what? What's M equal to what? Okay, so we have this one. So this one is gonna be a factor. It's gonna be x plus 3, right?
Yeah.
And this one is x plus 1, right? And this is x minus 3. Is that okay? But then you're gonna say, well, x plus 3 to the square times x plus 1 to the first times x minus 3 to the third. But if you realize that the y-intercept is not going to be a -4. In generally, if you graph this, it's going to have some type of much bigger, longer graph. So then you say, well, it has to be a value right here. That a value is going to structure that graph. It's going to like compress that graph in this certain way where you can have a y-intercept at -4. So the a value is going to be the same thing as what you did with parabola, because you do have a point, right? You have a point of a 0, 4. So can I put a 4 as the output? Can I put the 0 here? And then can I go ahead and solve it? Oh, -4, you're right. Nice catch. So this is a 9. This is a 1. This is a -27, I believe. So a is going to be -4 over 9 times 1 times a -27.
Like, like.
Yeah, I have no idea what is that, but I'm just gonna. What is it? -4 over what? It's 4 over what?
243.
243.
Yeah.
Okay, good. So 4 over 243. Now you're gonna say, well, why do we need that? Let's just plug in this on the decimal. That's why you need to check your answer on decimals. So I'm glad that Justine was honest to me. Says, hey, I didn't check on decimal. Gianna the same way, and I think there was more than those two individual. And Nicholas did too. But if you really want to be good at math, you have to check your answer. If you want to be good at any sports, you have to go back to watch films. That's just the way it is, right? You watch the film, you look at what you did wrong, how can I fix it? That part is actually more important than the practicing. Now, why your coaching asks you to watch the film, what you did, right? If you're rowing, does a rowing watch films?
Yeah.
You do? What do you do? Just
So our coaches are on boats next to us that drive, so they just video us while we're rowing.
so what kind of mistake you will make in rowing?
You go too fast, you're not in time.
You're not in sync.
Yeah.
Body angle should be off when you guys are getting
Yeah, so those are the things. Like in order for you like to row the fastest, you have to go in to correct your mistake. And if you don't willing to do that, you're always gonna be slow. That's just the way it is. It doesn't matter how many hours you practice too. You can practice a lot of time not in sync. Then it's actually worse, right? Because you practice the wrong thing. So if you don't check your answer, you're not gonna get better. So learn to check your answer, because every time you check your answer, you'll find something new, including myself. I'm gonna find something new. So I'm gonna go ahead and type in the decimals, and I'm gonna show you what I have. So it starts with x plus 3 to the second power, and start with x minus 1, x plus 1 to the first. It doesn't really matter, actually. It's multiplication, so it doesn't matter. So it, and then x minus 3 to the third, right? And looks like this. I mean, in generally, does that look like that? Yeah, but the problem is y-intercept is all the way here to somewhere around like very, very, very big number. So then you say, well,
It's 243.
yeah, and then you say, well, there's gotta be a way to do it. So we find out that it has to go to 0, 4. So the 0, comma 4, which is, it did not go through that 4, 0, comma 4. It did 0, comma negative 4. It did not go through that. And it doesn't really matter. The a value, if you plug in that point, you adjust the sign. You don't need to say, hey, let me change the sign because this a is positive. If you plug in that point, they will readjust the sign. So we say we got is 4 over what?
243.
And now it looks like that. The a value did dictate how my graph is gonna go. Almost exactly like that. We predict this is happening. We predict this. And if you don't have that y-intercept, there is no way you can structure, it can shrink that graph in. And because that a value is less than 1, so you're vertically compressed to where to reach the negative 4. Does that make sense? So those are things that you should have learned from different things. On SAT, they actually give you this graph. They say, oh yeah, this graph transfer up like 2 units. Then if you want to transfer up 2 units, just plus 2. And just, oh yeah, that's the y-intercept, negative 2. And that's, you know, same thing it happened just like the stuff we study is not changing. Does this make sense? Yes. Does this make sense? Okay, so you want to try one more or you got it? Okay, let's try one more. You got it? That's fine. Well, we can try one more because we want you to get better at this. So So we want a graph look like this. Huh? Can I give you the point? Sure. This is a -4. This is 5. This is 3, and this is 6. Like this kind of question is way harder than AP exam can ever give it to you. But I want you guys to actually understand the math. The math is actually very interesting because you can predict without graphing calculator, without decimals, you can figure out what a graph look like. Now, after you did it, I want you to check on decimals. Learn how to check. Learn how to check your answers. You guys have phones. Okay. You don't even have to evaluate that number. Just plug in the decimals, see if that number works. Can somebody get a door for him? Thank you. What kind of shoes is that, Josiah? What kind of shoes is that?
It's for Fridays.
Huh?
For Fridays.
Oh, okay. I know you're on cross country. You gotta wear. Wait, why you not in the meet? And don't they have cross country meet today?
Top 7.
Top 7. Wait, did RG go?
Yeah.
Did Bennett go?
No, Bennett's hurt.
What about Lucy?
Bennett went?
No, Bennett's hurt. He would have gone.
What happened to him? Oh. Yeah, that's what Katie had.
Yeah.
Katie's running.
Yeah.
5 or 6.
There you go. 8, 5, 6.
And I'll probably say this graph's probably like this. It's probably more like this.
How did you it go the other way around?
I can do it. It's probably look like this. And today, why end up there? It's not 5.04, it's gonna be 5. Has to be very precise going to 5.
Well, if the y-intercept was 10, that's the double.
We got the
Wait, no. That's what I put in. Oh, I wrote one mistake.
Hey guys, I did it correctly.
I did it right.
We did it right.
Well, I did it right before, and then when I rewrote it, so I accidentally looked up the
Okay, that sounds great.
Yes, I agree.
I don't know what 64 times 9 times negative 6 is. Negative 3, 4, 5, 6. Well, that's a weird number. It's better than 6, 7. Do you got a graph looks almost like that?
It's still 5.04 though.
No, that's the parabola.
I don't think so. 5 is negative 5 over 3, 4, 5, 6.
That's the wrong. You should have just.
No, you said it upside down.
Well, yeah, that's you should have had this.
I did.
Multiply it. Should have
Did you get to delete the other graph?
Oh,
64.
I see what you were talking about. Yeah.
Why did you get so many?
I think I put 59.
What did you say?
Wait, what do we say? What do we say the graph look like? Sorry, I forgot the graph look like.
It's negative. It goes down.
What's x plus 3 to the what?
I don't know.
X plus
I
x
don't
plus 4 to the power 3, x minus 3 to the power 2.
Hold on. X what?
X minus 3 to the power 2.
Okay, what else?
X minus 6, and that's it.
How about you start taking the SAT?
Yeah, so it looks like this, yeah.
You delete the other graph.
Yeah.
Thank you. It's good, yeah. I think we did right.
I done it.
The SAT?
Got it.
Okay, so if you realize that we predict this graph by just like looking at a graph, we can actually see what a graph, any polynomial in factor form that we can see. However, there are some times that there is a roots, but it will not show. So that's what we're gonna look into today is how about some situations that you will have zeros, but you don't have it showing. So for example, I'm gonna give you the situation here. So I'm gonna give you a question n equal to 3. So write down, say this means degree. If today you see homework questions that it says n equal to 3, that means the third degrees. And they say -4, hold on a second, -5 is 0. As well as a 4 plus 3i is a 0. And then f of 2 is equal to 91. So we have this situation here. Yeah.
Is that 90?
Yeah. 4 plus 3i. So I'm going to say this is x equal to -5, right? And then x plus 5, that's a factor. Is that okay? Now, then you're going to say, oh, this one just x equal to 4 plus 3i. Does that make sense? And I can move it to the other side, so it'll be -4 minus 3i. 4 plus 3i equal to 0. Now, Arthur's not here. I cannot make fun of him. Damn it.
Do it anyway.
You can still make it.
Yeah, he's gonna listen to me on the stream. Hopefully, right? So remember, we talk about Arthur is a sad boy, right? And so sometimes he will get like, when the b squared minus 4ac is greater than 0, then he got two real solutions, right? So he got two real, like maybe like an Instagram or a Snapchat, right? Now, what if n equal to, what if a discriminant is equal to 0? How many solutions you gonna get? One solution. And what if n squared minus 0 is less than 0? What if discriminant is less than 0? How many? Two imaginary, right? So this is Arthur. If he's gonna get an imaginary girlfriend, why not have two? Right? Why you have one? Okay, so yeah, so there is probably a good looking one and there's an ugly one. Nobody gonna imagine ugly one. Okay, so this is 4 plus 3i and 4 minus 3i. They always come in pairs. Okay, they always come in pair. 4 plus 3i, 4 minus 3i. You just change the number in front of that. And if you really think about it, if you do something that says x squared minus x, I don't know, plus 5, something like plus 4 like this, and if I were to do a quadratic formula, I would do 1 plus minus square root of 1 squared minus 4 times 4 over 2, right? So that's going to be 1 plus minus square root of negative 15 over 2. And that's equal to 1 plus minus I square root 15 over 2. See that plus and minus I here? Do you see that? That plus minus I is that the good looking girlfriend and the ugly looking girlfriend. That is imaginary, right? So this must have, they always come in pairs. If you have one type of I, they come in a pair. So they call it conjugate pairs. Okay? So this one must means this one also have this. Oh, sorry, this one's minus 4 plus 3i equal to 0. I just move everything to the left side, it becomes a factor. So that means x minus 4 minus 3i and x minus 4 plus 3i. Now in math, this part is kind of tricky. Devin, you gotta pay attention. Everybody, you pay attention. Darshini, Roger, Justin, you guys gotta pay attention because this part is a tricky part. If we have x minus 4 minus 3i, can I just put a parenthesis on the first two terms like this? I did not change your order of operation. You are at minus 3 and then minus 4. Then can I just say, well, x minus 3 minus 4 happened first? Now, if you pay attention, this is going to be a minus b times a plus b. So if a minus b times a plus b is equal to what? Difference of squares equal to what? Okay, so can I just write down x minus 4 squared minus 3i squared? Does that make sense? Does that make sense?
Oh.
Now it's going to be x minus 5 times x minus 4. This is x squared minus ax plus 16.
Wait, how's
But
it
what'd you get minus 5 for? Oh, plus 5, sorry. All right, so this one is going to be minus, what is 3i squared? That means 9i squared. That is equal to negative 9. Is that okay? So negative 9. So x plus 5 times x squared minus ax plus 25. But there was an a here. Why? because we have one last thing we can use. This is like the y-intercept before. Is that okay? So does the f of x equal to a? Now we're gonna use that point. We're gonna say, well, 91 is equal to a times 2 plus 5, and then 2 squared, which is 4, minus 16 plus 25. I have no idea what's that.
Real one. Oh, wait, where did you get 91?
91 is the part of the question. They say f2 is equal to 91. That means when you plug in 2 for x, the output's gonna get 91. So it's kind of like y-intercept before. The y-intercept is 0 and -4. This time it's 2 and 91. It doesn't matter. It doesn't have to be y-intercept. It could be any other point. Now here's the thing about this graph. You're not gonna see this 2. You're not gonna see this 2. You're not gonna see this 2x intercept because it's not visually appear in our dimension. It's in the imaginary dimension. It does happen, but it doesn't happen in this dimension. That normal dimension you can find. Yeah. So plug in. F of 2 is equal to 91. That means plug in 2 and equal to 91 for f of x. And then you can solve for a, and a is equal to 1. What'd you say? Yeah. Well, how much time we have?
2 minutes left.
2 minutes. I'll give you an easy one. So I say n equal to 3. This is part of homework. X equal to 4 and x equal to 2i. And the f of -1 is equal to -50. I want you to find a polynomial. Now remember, n equal to 3, this means what? Degree. F of -1 is equal to -50.
Wait, what's the degree for?
Yeah, degree is gonna, so this is gonna give you 1 degree, right? The -5 is 1 degree, right? This is gonna give you 2 degree because you got imaginary coming pair, the conjugate pair, give you 2 0. So this is 1 and 2. They told you like, oh, this add together is equal to 3rd degree.
So what was the final
Solutions is gonna be x plus 5 times x squared minus ax plus 25. And you can expand this if you want to, but you don't have to.
well, the A is 1.
So x equal to 2i. What's the conjugate pair of 2i?
Plus, yeah.
Plus 2i, and then what's the other one? Negative 2i, the good looking one and the ugly one.
So for the degree.
Sorry, I'm not attacking anybody. Don't get offended.
For the degree.
I just want to create imagery for you to memorize things.
The 4, the plus 2i and the minus 2i.
Yeah, so you had to move it to become a factor. So if you have x plus 2, x equal to 2i, then x minus 2i becomes a factor. You gotta move 2i over. Do you see how I subtracted this over to the other side?
Yeah.
And this x minus 4 minus 3i. F of -1 is equal to -50, yeah, according to the question. Your test is gonna be Tuesday. And it's gonna be on all polynomials and even on this and yeah. And we're gonna do rational function and then we're gonna do log.
You know what we're doing
Next Friday?
next Friday?
Probably rational functions. You guys got it or no? X equal to 4, what will be the factor? X minus 4. Is that okay? X equal to 2i, what's the factor? Minus 2i. Now remember, there is a imaginary negative 2i, right? So it cannot be x plus 2i. Now I don't need it to create extra parenthesis here, but I know that this will eventually equal to this. Like this, is that okay? Now, I should always multiply the I together. This 2 is together. What do you think if we multiply together? Which is what? X squared plus 4, yeah. Because this is A minus B, right? A plus B, right? If you times each other, what are you going to get? A squared minus B squared. So it'll be X squared minus 2I squared times X minus 4. A, f of X.
Thanks for another great day.
Now this is A, almost done. Just give me a second. 2I squared is going to be 4I squared. So that's equal to negative 4. So this is negative 4. So it's negative 4. So it's plus 4. Is that okay? And then we're going to say, oh, okay, well, we plug in, if I plug in negative 1, so it's equal to negative 50, equal to A times negative 1 squared plus 4 times a negative 1 minus 4. I don't need a square. No, what?
Degree too, for the second one.
No. It's first one. It's only first degrees. Negative 4. Is that okay? Am I doing anything wrong?
No.
It's okay?
No. Wait, is it at 5?
It should be
Negative. 'Cause it's,
Oh, this one's negative 5, right?
yeah.
Okay, what do you think is
So that's A is equal to 2, right? And yeah, so it'd be 2 times x squared plus 4 times x minus 4.
Do you factor x squared plus 4?
What do you mean?
Like, oh wait.
If you factor x squared plus 4, you will get x plus 2i, x minus 2i.
I got the same. You know the previous question? I got this.
Yeah.
I got the same. When I saw the screen, you put 3,000 something. Negative 3,000. Negative 5 or 3,000 something.
I don't know.
I got the same answer. I'm so confused.
No, it's probably right because you probably copied down the wrong question. The questions look like this.
It looks like that.
This, 3.
6, 3, 6. It looks the same. I was like, what the hell? Is anything wrong? I was like so confused.
No. The third one's wrong. The 6 is gonna go straight down.
Oh,
It's not to the first power. It's this one's to the first power.
so I made a mistake.
Again, yes. Don't make simple mistakes, like I say. Do it once, do it right.
Yes, sir. Also, close the street.
Oh, okay. Oh.